So last session we talked about we covered introduction to databases and how we can actually implement a database. We just reviewed the steps to build your own database. So we talked about collecting the requirements, if you remember, and then we said that this is one of the most important steps to know your business or application. What are the main functionalities? What is the objective? And so that was the first step. Okay, so the first step was that. And then what was the next step? So after you collected the requirements and you define the objective, you know what are the functionalities. What was one of the main steps? Yeah?
Modeling.
Yeah, data modeling. So next we have the data modeling, which in this class we do with entity relationship diagrams. And we covered that this week. And then what was next? After data modeling? Yep. Yeah, and then we had the implementation. At the same time, we had like this front-end application and the deployment. And finally, we also always have to take care of the database to optimize the database performance and do the recoveries. So the first step of your team project, which I already uploaded on eClass. So that is to write your project proposal, which is just one, maximum 2 pages. Each group have to submit just one proposal. Today we are finalizing the groups. So I also mentioned in the other class, I wanted to assign you randomly to groups, but I received like a lot of requests if we can like have our own groups. So I give you options. If you already know each other and would like to work together, you have to let me know today, and then I will, because I'm going to finalize groups soon, and you have to tell me, okay, and each group should be 6 members. So we 6 together, we want to like be in the same group. For the rest of you, I will assign you randomly using eClass. And I think it's good if you work with people that you don't know, because in real life, you cannot choose who you are going to work with, right? You go to a company, you're assigned to a team, and then you work with some people you didn't know before. And yeah, so that was for your project proposal and the first step in implementing in actually designing and developing a database. And today we are mainly focusing on the second step, which is the ER data modeling, which is the process of creating the logical representation of the structure of your database. And this is also one of the most important steps, because this is where later this ER model that you create is going to be transformed into your tables and your real database. So if you don't design it properly at this stage, you will later face lots of issues with your actual database implementation. So it's important to understand the entities, different types of entities, the attributes, the relationship, and the cardinalities, which we are talking about them today. And so we just briefly talked about some entities in previous week. So we said entity could be anything or a concept, like, for example, a person, an item. So it depends on the context of your project. Entity could be different things, and entities often have their own characteristics or attributes, right? They have some features or characteristics that we call them attributes. For example, when we are talking in the context of an e-commerce website, we said, okay, so product could be an entity, right? What could be other examples of entities? in, let's say, commerce website. Yeah. Yeah, customers, the employees.
Sellers.
Yeah, they're almost the same. Yeah. So these are like different entities which represent a thing, event, or a person in, for example, organization's environment about which someone wants to collect data. So this is actually what you want to later have tables for. So for example, you want to have a table for a product, you want to have a table for customers, etc. And then attributes are just those characteristics or features of each entity. For example, if your entity is product, so what are the characteristics of the product? Let's say your product is for example, book in a bookstore. So, anyone? Yeah.
ISBN. Link to the books.
Yeah. What else? Let's say you're designing a database for a bookstore. What could be a sample? Yeah, sample.
Price, author, name.
Yeah, so if a book is an entity, so what are the characteristics of the book that we want to keep track of in our database? So you have to think about these, like for your assignments or projects. So we say, okay, I want to keep this information about books, the book name, if there isn't like a unique ID, which I can use later as a unique identifier or a key. I want to keep the price of the books. I want to keep, for example, maybe some author information, or maybe you want to design a separate table for authors. So these are different features or characteristics of the entities that we call them attribute. And then another concept is relationship. So relationship is actually what connects the two entities together. So for example, again, back to our e-commerce context example, let's say you as a user or customer want to buy a product, right? What connects you to the product? So you as a person, as an entity, and a product, for example, a book as another entity, what connects you is the purchase action, right? Or for example, renting actions, buying actions. So this is what we call relationship. So for example, in the context of a university, let's say I'm an instructor, I'm teaching a course. So what connects me to a course is teaching, right? So I teach a course, and or students enroll in a course. So relationship between the students and the course will be enrollment. So it's often like when you are defining the names for your entities, attributes, and relationships, it's just a common thing. You often use names for attributes and entities, like for example, book, student, class, this. And then you use verbs for relationships, for example, because relationship refers like to those actions or that things that connect, right? So for example, purchasing or enroll. So these kind of verbs. It depends on your example. And then we also have a composite entity or associative entity, which we also explain it better later, which represent both an entity and relationship. That is mainly used for relationships that have M-to-N or many-to-many relationship, and I'm going to better explain these different types of relationship when we talk about cardinalities. So here are the components that we work with. So entity, you represent entities with this rectangle. So this is just an object or concept, like as I mentioned, product, customer, student, professor, course, and so on. And then we have attributes that we represent with these oval, and this describes the characteristics of your entities. Then we have the relationships and composite entity, right? And this composite entity or associative entity is just when you have many-to-many relationship, which I'm going to explain in a bit. So this is just what I explained about the naming conventions, like you using nouns for naming entities and attributes, like for example, customer, product, instructor, etc., and verb for relationship, like enroll, teach, buy, and so on. And this is just a suggestion for how to write a good name. So let's see in this slide which ones are entity, which ones are attribute, and which ones are relationship, right? It may change depending on the context, but overall, what could be, for example, a student name? Is it an entity, attribute, or relationship? No, everyone. What? Entity? How many of you say a student name is an entity? Okay. How many says it's attribute? Okay, good. Is an attribute. Salary. Attribute. Employee ID. And course. Entity. Invoice. Teach. Search. Yeah. And product category. Yeah. Again, depending on the context, this may slightly change, but it could be attribute as well. Unit price. Product. So we already had entity. Product description. Attribute. Quantity. Attribute. Buy. Relationship. Shopping cart. Let's say car first, and then car alone, entity. So if you want to like shop, relationship. So this is the different symbols that you learn for for example, attributes, or for example, using rectangle for entities, and so on. So in this case, shopping cart means like buying as a verb, so representing the relationship. So what I'm going to suggest you to use to draw your ER models for your ER modeling is you can use this website, ERD Plus. So this is very straightforward. You can sign up and log in, or you cannot. I didn't. If it's free, you can do it. But even if you don't log in, you still can draw your ER model, and we'll try it today together so you can see how it works. And then the good thing is that you can import it or like export files there without even having an account. So here is just an example of the ERD in the ERD Plus. So I'm going to show you how it works in a bit. So as you see, for example, you represent the entities, such as, for example, products, customers, etc., with this rectangle symbol. And then you show attributes for each entity with the oval. And then you have a relationship with the diamond. So here it just shows you the button in the ERD Plus that you can work with. So for example, you have select, entity, attribute. For example, if you want to create a new entity, you just click on entity, and then there is a window on the right where you can, for example, write the entity name, etc. And we are going to practice this together today. So let's see how we can build an ER model for example, a student registration system, the example that we already had also last week. So here in this slide, can you see, or I have to zoom? Or maybe I can tell you what are what are the different columns. So we have classes, we have class title or class names, and we have the number of enrollments in each class. We have days and times of the classes. We have rooms and class dates. So do you think that classes are entities or attributes? Class itself is an entity, right? But if it's a class name, a class, for example, room, etc., or other characteristics of the class, then it will be an attribute. So all these columns are related, for example, to information about the class. So, for example, here is what we are going to do with the ERD Plus today. So we are creating entities with this rectangle, for example, for the course, instructor, and the student. And then how do we, for these three entities, what are the other examples of attributes? For example, what are example attributes for the course? What are the course attributes? Yep. Yep. Course ID, name, yeah, and yeah, instructor information. Then, what are the characteristics of the instructor that we want to keep track of? Yeah, instructor ID, name, maybe the courses that this instructor teach. Or for example, office location, some other information that we want. And a student, yeah, again, a student number or a student ID, a student name, or for example, which year the student is in, what field the student is. For example, is in, for example, a computer science student, third year, etc. So this is just a screenshot from the ERD Plus. So this is how you can define an entity. So you just click an entity. I'm going to show you just a few minutes later. And then, for example, let's say you click an entity and then you're having like this rectangle here. Then here you can identify the name for your entity. And then there are different types of entity, like regular, weak, and associative. So for now, we focus only on the regular one. I'm going to explain weak and associative entity later. So just to work a little bit with the ERD Plus, you can just select the regular one now. And attributes, as I mentioned before, they just are characteristics of your entities, right? So for example, we can have employee ID, name, department, job title, salary. So these are the different information that we would like to store later in our tables for employees, right? We want to see what is the salary of this employee, or for example, which department he or she is working at. And we have also, when you're going to define attributes in your ERD Plus, like here, as you can see, we have like different types of attributes, like unique attribute, multivalued, optional, composite, and derived, right? So these different types of attributes, I'm going to explain now. So for example, if it's a key attribute, it means that it can uniquely identify that entity, okay? Which will later become your primary key in a table, right? Because the entities in your ER model are going to translate to your tables. So if you have an entity for a customer now, it will be a customer table later, okay? And these characteristics or features or attributes of the, let's say, what was the example entity I just mentioned? Class, course. Okay, let's say course. The course entity, let's say if it's course ID, name, etc., these will be the columns of your table later, okay? And so if an attribute is defined as a key or, for example, a unique attribute, then it will be your primary key of your table later. For example, a student ID can uniquely identify each student, and this can be a unique identifier for your entity and later for the student table. And we have single valued attribute or multi-valued attributes. So multi-valued attributes is just the ones that can have multiple values. Like, for example, let's say if for a person you're storing, let's say, phone number, a person can have different phone numbers, right? So it can have, like, a phone number can have different values. And then we have also composite attribute. Composite attribute, please don't confuse it with the composite entity. You can call the composite entity associative entity, just not to confuse. But there are different things. That is about an entity that deals with connecting two entities in a many-to-many relationship. But here we are referring to a composite attribute, which means that attribute is consisting of different parts. For example, let's say if your attribute for a person or for an employee is full name, right? Full name consists of first name and last name. So this is called a composite attribute. And, or for example, can you give me another example of a composite?
Address.
Address, exactly. So full address can include a street number, right, apartment number, and different parts. So this is also another great example of composite attribute. And then we have a derived attribute, for example, years of employment. So derived attributes are the attributes that their value is derived from other attributes. So what do I mean? For example, let's say in a table you have, you're storing, for example, employees' information or a person's information. You have date of birth, right? And because you have date of birth and you know what day is this today, so you can calculate the age of the employee, right? So the age, you can later, for example, create a new column or attribute for this person as age, right? And then age can be derived from date of birth. So that is what derived attribute means. So this is just a better example. So we have a student. A student can have, for example, name, right? And the full name, what type of attribute is full name? Composite attribute. Why? Because it has multiple parts, like, for example, first name, last name, right? And then we have, for example, birth date, which is just a normal single value. Yes?
So are the first name and last name, are they attributes too or no?
Yeah, they are. Yeah. And then we have age, which is derived from, for example, birth date. So it's a derived attribute. We have phone number, which is multi-valued, and roll number. So I assume that this is, like, for example, a student. You can assume it as a student number, right? Which is a unique identifier for the students. So this is, again, showing you how to, for example, add these attributes and their types in the ERD+. The reason I'm not going to ERD+ right now is just I don't want to interrupt the recording. Whenever I exit this, it just always stop my recording. So I'm going to cover this first, and then we will do this example together with ERD+, and that's super easy. And yeah, so you see, for example, we are on the student entity here, where we have a student number as the unique identifier. So this is your key, right? And then we have a student name. And if this is It depends on you. Maybe you want to like have a student first name one attribute, a student last name another attribute, and then you won't have any composite attribute. But I would suggest have like full name as a composite attribute with two attributes, first name, last name. Or for example, when you have address, so you have address and then a street, for example, zip code and other components of the address as other attributes. And yeah, and major, and you can have like, you can store many more attributes. It depends on you. These are just for example. These are not the complete list of attributes for these entities. And relationship, as I already mentioned, it relationship is what is between the entities, right? And define how these two entities, for example, are connecting to each other. For example, when you want to connect here, if you want to connect the course to, for example, instructor, so you can connect them through a relationship, okay? So you add a relationship from here. So you click relationship, then a relationship will be added. And then you have here, you can select, for example, which two entities this relationship is connecting to. For example, if the relationship that you are assigning or defining is between course and instructor, what could it be? How course and instructor are connected to each other? Yeah, so an instructor teach a course and the course is taught by an instructor, right? And even though I have not covered the cardinalities yet, but I would expect you can, because these are just something logical, so I would expect that you can tell me what are, you should be able to tell me how is the relationship between the course and instructor. For example, I give you an example. A customer can buy many products, right? And a product can be bought by many different customers. So this is an example of a many-to-many relationship. So from both sides, from both entities, there are like these many options. Or for example, if I talk about a student supervision by different like professors, let's say a PhD student, right? A PhD student, we assume that can have only one supervisor, right? But each supervisor can supervise one or more PhD students. So this will be an example of a one-to-many relationship because one supervisor can supervise many students, one to like more students, to many students, but each student can be supervised by only one supervisor. And that these are all depending on how you define your business rules. So back to your project. So in your project, the first step was the proposal and then defining the requirements. So when you are defining your requirements, you have to make sure when you write your business rules, you have to make sure you define these relationships carefully. So for example, if I assume, and you can have, like sometimes you can have simplified assumptions. For example, in your assignment 1, you are going to a flower online flower store, and then you are seeing, for example, what options are available, what are the functionalities, and you realize that if you check the website, you see, for example, when you buy, for example, when a customer order a flower or products, this can, for example, contain multiple products and they can have, for example, different types used for different occasions, right? For example, for anniversary, for birthday, etc. So sometimes if you see that your ER model is getting too complicated, you can make simplified assumptions. And I give you examples of simplified assumptions. So for example, you can say, okay, there is a many-to-many relationship between order and products, but I'm going to assume that there is one-to-many relationship because I assume that, for example, each customer can, for example, order only one product, but each product can be ordered by many customers. And this is just one example. So, but if this is your assumption and this is what you wrote in your business rules, then later you have to, your ER model and your tables design should reflect that, not a many-to-many relationship. Or if your business rule define a many-to-many relationship between, for example, a customer, a product, and an order, and then there should be a many-to-many relationship later as well. So they should be consistent. So here is just an example. For example, the relationship between professor and student. If you assume that each student can have more than one supervisor, like for example, I had 2 supervisors in my PhD. So in this case, what would be the relationship between supervisor and student? Anyone else? So it's very easy. If you want to define a relationship, you can just tell this to yourself. Okay, for example, for the professor and student, does each professor, for example, can supervise one or many students? If each professor can supervise only one student, right, and each student can have only one supervisor, then this is a one-to-one relationship, which is just for assumption, right? This is not correct because each supervisor in reality, each professor can supervise many students. Now, sometimes, like in most cases, we see that supervisors or professors supervise different students, but each student often have only one supervisor. And in that case, the relationship is one-to-many. In what case it will be many-to-many? Yeah. Yeah, if you have multiple supervisors, like in my case, because a student can have one or more supervisors, and also supervisors are supervising one or more students. So in that case, it's many-to-many. And enrollment is a relationship between the course by student. So for example, a course, a student, one student can be enrolled in many courses, right? You can take database course, AI course, machine learning, etc. And each of these courses have enrollments with like many students, right? For example, there are many students enrolled in database, AI, etc. So here, so go to ERD Plus now, and let's practice this together. So I already provided the link in, even if you just erdplus.com, it should pop up here. So you just click this link. Okay, this is good. Okay, try not to check the S slide and see how much you have learned. So everyone access the website. Okay, now here, if you just click on try it, so you can just try it here, and I'm going to zoom so you can see. Okay, so first of all, let's only focus on the three main entities that we've covered, right? So we are talking about the student registration, and we said that we have like different entities like students, we have courses, right? And we have also instructors or professors. So you click on entity, and then you have here, okay? So now I can, for example, write course. So I have an entity called course. And for now, just we select it as a regular entity. So weak entities, associative entities, we already explained. Weak and supertype I will explain later. So course is just a regular entity. And then we want to have another entity, for example, a student. And then another entity like professor or instructor, maybe better. No, actually, okay, so now what are the attributes for the course? So you just click on the attribute here and then add the attributes that we already talked. Like, for example, we have course number or ID. And this will be your unique identifier, right? So you just click unique. So this will be on the underline here, shows that this is your unique identifier for the entities, which will be later be your primary key. And I'm sorry, just I forget one thing is that, okay, let me delete this. So for the course, when you define an entity here, you can add attribute like at the same time. So now I add attribute for this so that it connects to the entity that you want. So now I write course ID and I define it as a unique identifier, and then I add another attribute, like for example, course name, which is like regular, it's not multivalued, composite, etc. So I add another attribute. What could be another attribute for course? So if you have a course table, right, what characteristics of it do you want to store in your table, right?
So why is course name not unique?
I mentioned it last week. So if you assume that the two courses cannot have the exact same name, okay, so in that case, you can use it as a primary key, but it's always recommended to use like a numerical value, like a unique ID or something. Also for like the optimization purposes, because they store like less space. Also later there might be a course with the exact same name, or for example the courses that have different sections. So again, different sections, they have still the same course ID, so we might have like another attribute for the section, but it's better to have it as an ID. It's like, for example, you say the email, we're using email for a person as a unique identifier. But later when you work with databases, you see it's easier to have like these numerical values as the keys, like IDs. Maybe later, like a student update, for example, his or her email, or use another email. So it's safest to use the unique identifier like these. Then you can have course, maybe course description, right? And what else? So what are the like example attributes for the professor? Similar to like a student and course, right? So again, we have, you just add an attribute like employee, maybe number, and this employee number is a unique identifier, right? So you click it as a unique identifier, and then you have professor name, right? And the professor name could be composite, right? Because it can have like the first name and last name. And then you can also, you see here, add component attribute. So you just add these and then write, for example, first name and last name. Last name. Which I have it here. And then for a student, the same. So we have like, you add attribute, a student number as a unique attribute, and then you have, again, name. I'm not going to put it completely now, but you know it is a composite, right? And then, so back to your question, for example, now that for each student, we can have list of, for example, courses that he or she is enrolled in, right? But are we going to store them in, like, all of them in the same table? Maybe not, right? So we are storing like these courses in a separate table as course, and then later when we are linking like these two tables together, we can see which courses a specific student took, right? Instead of having, for example, a student name, for example, Mona, and the courses like this. So we see that we have a separate table for courses, but we have a common link between these two tables. So there should be a common field or common attribute between the two tables that you want to later join to like search for information. For example, if you want to see an employee that is working, for example, you want to see which employee or a specific employee like me, for example, Mona is working in, for example, ECS department. So you want to search for this information. So in the table that store employee information, that is me, you can only find employee ID, employee number, and maybe, for example, department ID, okay? But if you want to have, for example, find the department name or more information like the location of the department, right? You have to join these two tables, which are the employee and the department table, right? So that you can find the location of the department that I'm working in. And what is the attribute that connecting this employee table with the department? There should be a common field when you want to join, right? And that common field can be, for example, department ID. So you have to put this department ID in the employee table. So that, back to your example, could be another design option, right? So you have like have all these courses, and then you can join these two. You can see what are the prerequisites, and then join them to get the list of courses that are prerequisite for a specific course, right? Or for example, joining tables, for example, a student and courses to see, for example, which, for example, courses in total, list of courses that a specific student is enrolled in. Okay.
So can we make like a prerequisite courses attribute, a composite attribute, and each of the components would be unique IDs of the different courses, and from that unique ID, which is
if prerequisite, okay. If let's say we do what you say and we make the prerequisite as a composite attribute.
Yes.
So what are the components?
Components are the course IDs of the prerequisite courses. So let's say there are 3 prerequisite courses, course 1, course 2, and course 3, and the components of the prerequisite course attribute are course 1's unique identifier, and the second attribute, second component is course 2's unique identifier.
And then if we have hundreds of courses, are you defining 100 attributes? So that's the
Yes,
difference that I mentioned. No, that's the difference I mentioned, that this is not a composite attribute. So the composite attribute, when we are talking about the composite attribute, is an attribute that is composed of different parts, right? So for example, the name is, I think, the best example. So a full name consists of first name, last name, right? So it doesn't make sense to have like, let's say, hundreds of like courses, course 1, course 2, course, because course 1 is not a characteristics of a course, right? Course 1, course 2, these are not the characteristics of these prerequisites. I'm not sure if I'm clear, but another example that your friend mentioned, like the address, when you talk about the address, is composed of, when you write the address, it's something specific, and it's like the same for all values or all rows related to that field, which is address, right? All addresses have a street name, all addresses have the city, all addresses have the zip code. Or for example, all full names consist of first name, last name. Yeah, but that's not the case with your example. So we cannot have like a prerequisite course as a composite attribute and then have course 1, course 2 to course 1000 as the attributes. And it's not even like, from the design point of view, it's not feasible, it's not efficient, and then later all these attributes are becoming your columns in your tables later. Yeah, so let's get back to our example. So we have a student number, a student name, again, as an composite attribute, right? Because it has first name, last name. I didn't add it here, but you can see it's the same as professor. And other attributes that, for example, you want to keep for the student, right? So if, for example, you want to connect the student to the course, what do? Yeah, so you just add a relationship here. So what is the relationship between a student and a course? Let's say, how many courses can one student take? Yeah, it can take 1 or more courses. So, and how many students can be enrolled in one course? Again, 1 to many. So when you are defining the relationship between two entities, always ask these 2 questions to understand what is the cardinalities. So in this case, each student can be enrolled in many courses, and in one course we can have many students. So you have to use both sentences, right? So if only I saw, for example, in the past, students say, okay, each student can take many courses, so it's a many-to-many relationship. No. If a student can take many courses, it doesn't qualify it for any, like, defining any type of relationship. You have to see the other way around too, right? So how many students can be enrolled in courses? And then you can conclude that, okay, it's a many-to-many relationship. And okay, so you click on the relationship. Now you see here, you have these different, you can also have a name here, a student enroll in a course. Like, you can ignore this for now. And you have the option for the entities, right? So which 2 entities you want to connect with this relationship? For example, course and a student in this case, like entity 1 is course, entity 2 is a student, right? And then for each of them, you have like these different options that I'm going to explain. Like, for example, a student can enroll in, we said it's a many-to-many relationship, right? So here is the course entity. So when you select the many for the course entity, it means that in each course we can have many students, and then each student can be enrolled in many courses. So this is a many-to-many relationship. And then we call this kind of relationship whenever you have a many-to-many relationship, you can define a associative entity or composite entity that I explained are to handle the relationship handling the many-to-many relationships. So, and in that case, and this is because if I'm going to explain you later with the tables, with the real tables, if you don't put let's say a mediatory or intermediary table between these two tables that have many-to-many relationship, you will face like lots of logical issues later. So this associative entity is to address that problem that I'm going to explain later. Now the focus is only on the ER modeling. And so then we have, for these associative entities, often they have like a common key, which is a foreign key that was primary key in the other two tables. So the primary key of the two entities will become, or the two tables that is connecting to, will become its foreign key. And the reason, do you know why is that? For example, now the enroll can have like two attributes, a student number and course ID. And these two, like these are the unique identifier or primary key for these two, but later will become foreign key here, right? Do you know why is that? Why does it have like these two attributes? Yeah.
It's not unique, so it can't be like the primary. So it has to be
Yeah, sorry, my question, I rephrased my question. My question wasn't why is it a foreign key, but why does it have like always these two attributes?
because the relationship is between those two entities.
Exactly, because connecting these two entities, right? And later when we want to join these two tables, we need like this common field or attribute, and that's these two primary keys. So if you see here, it's back here. Okay, if you see here, okay, so we were in the student and course. So we said each student can enroll in many courses and each course can be enrolled in a student. So you can see it here too, maybe in later slides when we define it as a composite entity. Yeah. Okay. So this is how you show the composite entity. So I just wanted to show you this. So this means that when the relationship between two entities is many to many, instead of just having that diamond with many to many, use this associative entity. Associative entity has the entity symbol with a diamond inside, it. So it's this one, right? And now it breaks a many-to-many relationship into two one-to-many relationship. That's the point. So you want to get rid of always in your design, like most of the time, you want to get rid of many-to-many relationships. How do you do that? Whenever you have a many-to-many relationship, break them into one-to-many relationships. How? Using a composite or associative entity. So now this, for example, is not many-to-many relationship anymore. Instead, we have this one-to-many. So you have a student ID. Okay, this was what I wanted to show you too. So the primary keys of these two entities will become attributes of this associative entity. So always in your ER diagram, I'm going to repeat, when you have many-to-many relationship, break them to one-to-many, use associative or composite entity in between to do that. And then what would be the, like, if you couldn't think about like the enough attributes for that associative entity, like the minimum entities that you can draw are the primary keys or unique identifiers of the other two entities, which in this case are a student ID, will be attribute of this as well, and the course ID. And the reason is obvious because we want to join these tables later, right? So this way we can break this into a one-to-many relationship. I'm going to explain it later, like explain it more. We will see more examples, so don't worry about it. So back to our example, just you can complete it later at home. I just wanted to show you how you define entities in ERD Plus, how you define attributes and relationships, and then also for each of the same. So for the relationship, always remember to have, like, if you click on the relationship, you select the entities that it's connecting to, and then you can also say whether it's a mandatory or optional. And what is that? So we'll see more examples later too. But when for example, you have a case where, for example, for each course, at least we can say at least one student should be enrolled in, right? We can't say no student can be enrolled in a course because then a course is canceled, right? So in that case, it's a mandatory, it's not optional. But we may have a product that no one buys it, right? A customer may not buy this product. So that would be an optional. So we'll see that too. So for example, if it's a mandatory relationship, then you just click on the mandatory. And if it's optional, you just click on optional, right? And this is the difference. So if it's optional, you have this oval here. And if it's mandatory, then you have just this, this line here. So whatever we have been talking about, like these relationships so far, is actually what I want to discuss now as cardinalities. So cardinalities just define how many instances of one entity can be linked to or associated with the values of or instances of another entity. Like, for example, one-to-one, that is, there is a one-to-one relationship between two entities. Like if you say each professor can only supervise one student and each student should be supervised by only one, for example, professor, in that case it's one-to-one. But that was just an example. In reality, it's one-to-many or many-to-many. And then we have one-to-many or many-to-one, and we have many-to-many relationship. So these are the signs that we have been talking about. So if you have like this oval, means it's optional, but whenever you have this is mandatory. Now in this side, and if you have, unfortunately I can't write in the whiteboard, but if you have one-to-many relationship, for example, like here you see a one-to-many. So here shows the exactly one, and here shows the many side. So this is the sign for many. And for each of them, either the one or the many, they could be either mandatory or optional. If it's mandatory, you just add this. And then if it's optional, you add this over. And this is not always the case, but let's say each man, for example, marries one woman, and each woman marries one man. At least at the same time, and one-to-many relationship, like the relationship between the instructor and courses, right? Because each course, we can assume that can be taught only by one instructor. If that is the case, then it's a one-to-many. But if in your assumption you say each course can have more than one instructor, then it's a many-to-many relationship. Another example of many-to-many relationship is a student and course. Like, for example, David can take 3K, like different courses. Let's say these are the course codes. And then each of like these courses itself, they could also have enrollment from many students. And this is what I explained about associative or composite entities. Whenever you have many-to-many relationship, please break them down into two one-to-many relationship. And so here you see how it resolved the issue for the many-to-many relationship. So for example, back to here, for the many-to-many relationship you see here. So now when you add this enrollment as an associative entity, then you can say, okay, so we have 3KD3 David. So this is a course code and this is the name of the student. And so this is what you will see in the enrollment table. So in the enrollment table, you will at least have these two IDs as a foreign key here. So this is a just more complete version. Let's see it together. So for example, the relationship between instructor and course here is defined as 1 to m, and then course and the student, many to many. But here it breaks it down into one to many relationship, right? Now each student, right? Each student can have many enrollments, but like each of these enrollments then is associated with a specific student, okay? So here we have a student number, we have a course number, and we have a grade. And that is why it can be associated only with one sample. And that is how it breaks it down into one-to-many relationship. It's the same with the course. Here you both have the course number in this table and the student number, which can uniquely identify each rows. So what would be the primary key here in the enrollment table? Yeah?
It's course number and student.
Yeah. So it's not that always we have one attribute as a primary key. Sometimes you can have more than one attribute identifying your primary key. So the primary key, for example, for this table later will be course number and student number. And we'll call it a composite primary key, and we'll discuss it later. And then the student and instructor, we already explained. Each instructor can advise many students. Each student is advised by only one instructor, so it's a one-to-many relationship. So this is actually a very important table because it has all the information about, for example, which courses each student take, right? And shows enrollment for courses. So it's enough for now.